So what we're looking at today is compound inequalities. We looked at them yesterday. We wrote them out and kind of looked at the graph and made those. But what we're going to look at today is solving compound inequalities. And there's two main types. There's and. This one here where we have a variable in the middle is an and compound inequality, or we have an or compound inequality. Or are always two statements. They're two individual statements. Now this one here is an and inequality. And so what I'm going to do for this first is move this out of the way. The color I want. Bigger. Now I don't want you marking that out on your paper, but if we had something like this here, because we've done one like this here before, yes? What would we need to do to get the variable by itself if it looked like this here? Well, we need to move the 2, yes? So what would we do? I would add 2 to both sides here, yes? Okay, well, that's not what we have. We have this here, yes? We treat it like it has 3 sides. We have the one on the left and right and the variable in the middle. So to get x by itself, we needed to add 2. Well, we do it to both sides as well. So whatever we do to the middle to get the variable by itself, we do it to the left side and the right side. Because if I add 2, well, negative 2 and plus 2 gives me 0, yes? So I will have x in the middle. Now we can add it on the sides. Well, negative 4 plus 2 is negative 2, and 3 plus 2 is 5. So what we do to the middle for an and statement, we would also do to the two sides. So I can add something to all 3, or I can subtract something from all 3, or I can multiply all the way through, or divide all the way through. Any questions on how we did this here? We good with this here? Now to graph it, we'd have a number line, yes? And on the review sheet and on the test, I will give you the number line. You'll already have it given to you. And now we need to put 2 circles. So are these both going to be open, closed, one open, one closed? They're both open because neither one of these is equal, yes? Do I shade on the outsides, middle, one, or in the middle, yes? Because when the variable is in the middle, we shade in the middle, yes? And that's it. Questions on this here? Have y'all done these before? Y'all done inequalities before. I think this is new, yes? And that's it. Now, where we add 2 to all 3? Yeah, and really kind of think about it if you're having trouble with imagining or visualizing all 3, what do we do? Look at 2. So I think the next one is an and. So if you're having trouble seeing what do I do with this here, okay, I'm going to cover the 9 up. And look at this here. So I'd cover this up and say, okay, I've got negative 3 is less than negative 2x plus 1. I wouldn't scribble over the top of it because it's easier for y'all on the paper, or if you're working on the assignment, you can cover it up with your hand or cover it up with your finger and say, okay, what do I need to do? So when I look at this here, negative 2x plus 1, and we have negative 3. If I want to get the variable by itself, I need to move the plus 1 first, yes? So how could I do that? What would we do? We would subtract 1, yes? Because 1 minus 1 is 0, yes? It gets rid of it. Now, this is where I'd uncover this because, again, we do it to all 3 sides. So I cover that side up to see, okay, what do I need to do? Because we're used to it having only 2 sides, left and right, not a left, right, and middle. So I'll cover one of them up and see, okay, with the 9 covered up, okay, if I minus 1, I'm closer to getting x by itself. We do it to all 3. So negative 3 minus 1 is negative what? 4 less than negative 2x is less than or equal to 9 minus 1 is 8, yes? So is x by itself? No, what's with it? The negative 2, yes? Thank you. So how could I get, have a good weekend, how could I get the negative 2 to go away? Well, they're being what? Multiplied, divided? They're being multiplied, yes? So to undo multiplication, we divide, yes? So I'm not going to divide just two sides by negative 2. I'm going to divide what? We're going to divide all three of them by negative 2. We'll divide all three sides by negative 2. Well, that'll give us x here. Negative 4, well, negative and negative make a positive. 4 divided by 2 would be? 2, yes? So we get 2 over here. 8 divided by 2 is, and it would be negative, yes? Our signs are going to change. Why? Anytime we multiply or divide by a negative, we have to change the sign. So this goes from less than to, this goes from less than or equal to greater than or equal to. Is x still in the middle? So when we graph, we're still going to shade in the middle. It doesn't change that. So what number would go here? Negative 4. And this would be 2. So one of these is going to be filled in. It would be what? The negative 4, because it has the equal to. And that'd be the only one, and we shade in the middle. So on the homework, it'll be nice, because they will give you the number line already where negative 4 and 2 are set up. On the review sheet and the test, I'm just going to give you a blank number line. Okay? So that way, you can do like we've been doing here. Make a mark for negative 4, make a mark for 2, fill in the information. Okay? Any questions on this here? 1 over a number? Yeah, let's look at that. So let's just, I'm going to make one up. Let's say negative 6 is less, oh, what is that? Less than x over 4 minus 3 is less than or equal to 7. Something like this here? Yeah, let's do this one. So the first thing I need to do to get the variable by itself would be what? It's with the 3, isn't it? So we would add 3 to all three sides. We'd add 3 to all three sides. And looking just in the middle, well, these two would become 0. They would cancel out. X over 4. So negative 6 plus 3 would give us negative 3. And then this would be 10. Now looking at this here, x over 4. So it's a fraction. But what would we consider those doing? What is the operation working between x and 4? Because this is division. There's another way to write division, yes? So what's the opposite of division? Multiplication, yes? Yes. So, like this here, because if, I'm going to erase this for now. So if we had this here, we would multiply both sides by 4, yes? Because I'd multiply this side by 4, and we multiply this side by 4. Because we're comfortable with that, yes? So when we add this here, we're just going to multiply all 3 by 4. So it's very similar, it's very similar when we just had two, a left and right. We didn't have left, right, and middle. But our operations that we do apply to all three. They just apply to all three. So here, -3 times 4 is going to be -12 is less than x because these cancel. Now, 40 is going to be filled in, open, and this here. This is also another positive, doing it this way, because you don't have to worry about actually spacing that out. If we were going by ones, that number line would be huge. For an and statement, x will not be on the side. Normally it won't be on the sides. If it is, we just add it and move it in. For what we're covering and what we're doing, I won't, Kendall won't, we won't put them on the sides. But, so something like this here. So I would watch this one. Don't copy this one down, because this is above and beyond what we're going to do in this class. So if I notice that there's variables on either side, I want to move them all to the middle. So I'm going to move this x first. And what I'm going to do is I would need this to be x. I'm going to subtract it from all three sides because I'm moving it. And what that would do is give us 6 is less than or equal to, well, 2x minus x would be x is 2, and that would just give us 7. So when you try to do operations to get it in the middle, here in an and statement, we don't really deal with variables on all three. Then we can add 2, get 8 is less than or equal to x is less than or equal to 9. So normally we'll deal with it just on one side or the other, because once we get so far, it's hard to get it all on the same side because we're having to apply it to all three. Do we feel comfortable with these here? Does this look really easy now? Yes? So what would we do with this here? Yeah, -1. Is less than. That's it. That's all we have to do for this here. Any questions on this here? Not as bad as what you thought it might be? Do we need to see another example of one of these? Okay. If we feel comfortable with those, we'll look at OR. If you don't feel comfortable or questions come up later, please ask. Please ask. I will do more, because if they feel comfortable now and they don't later, just ask. I will recover that. Now, with OR statements, we have two separate statements, yes? The OR statements we worked with yesterday, did we ever combine them into one? Well, no, we always kept them as two separate statements, yes? Here, we're going to do the same thing. Now, it might be helpful. Wrong one. This one here. you don't need arrows, but kind of drawing a line down the middle and splitting these two apart because they're going to be separate. You're just solving one of them at a time. So, and because it worked out that x is in the middle, it's what they have in common, I can solve both statements at the same time. Because that's what we really did. We solved the two statements at the same time for and. And I'll kind of show, because that was a little confusing. Yes, both statements. What do you mean both statements? Because any and statement this way is really two statements. Because we have two inequality signs, it's really two statements put as one. Don't think too much about it, but it's really, we're solving two things at once. It's really what we're doing with an and statement. And it's written as one. Here we have two unique statements, yes? So you just solve them one at a time. So it's not much different than what we did the other day. It's just we have two of them we're doing together. So if I look at the one on the left, I need to get y by itself. So the first thing I would do is we're going to add 5 to both sides. Because negative 5 plus 5 would be, whoa, they would cancel out. And what that would leave me with is 3y less than negative 3. Because negative 8 plus 5 would give me negative 3, yes? Now what do we need to do next? Because we still have 3 times y. So to undo multiplication, we're going to divide. And it's going to be 3. And we get y is less than negative 1. So we have one of our two statements done. Now we just do it again. Now we just need to solve the other side. So again, we need to get 2y by itself, or y by itself. So we have 2y minus 1. So what do we need to move first? We need to move the 1 first, yes? Because it's easiest to move first. So since it's negative, we're going to add 1 to both sides. Because negative 1 plus 1 would give me 0. And we'd have 2y is greater than 6. Then what do? We divide by 2. And we get y is greater than 3. Since we have an or statement, we're going to take both of those. We're going to take both of them. We take everything on an or statement. So the circle is going to be both open, both closed, one open, one closed, both open. So y is less than negative 1, so we shade to the left of negative 1. And we shade to the right of 3. And that's it. Questions on this here? So how do we feel with these? Good? Y'all need to see more of these. We feel comfortable with this here? Okay. If y'all feel comfortable with this here, we'll be done. Let's see here. I want y'all to watch this one here. I'm going to change this up just a little bit. I know the signs, the inequality signs are flipped, and I did that for a reason. Okay? So if we were to solve this, well, the first thing we would do is to subtract 3, yes? Because 3 and 3 would cancel, giving me 4c is greater than or equal to negative 8. Then we divide both sides by for and get C is greater than or equal to -2. We're good with that, yes? Because those are just what we've been doing, just at a little bit faster pace, yes? Here we would add 8 to both sides and get C is less than 7, yes? So on a graph, -2 and 7. At -2, it's, at 7, it's open. Now at -2, are we going to shade to the right of -2 or to the left? To the right, yes? It's bigger than -2. Oh, wait a minute. That one ran straight through 7, didn't it? Okay, let's see what happens here. C is less than 7. I would shade to the left, yes? Did I just shade the whole number line? This here is all real solutions. If it works out that an or statement, the two number lines are going to point towards each other, like an and, it includes everything. Think of or statements. When an or statement's true, it only has to apply to one. Like if you're given a choice between 2 items, you only have to choose one. I mean, you could choose both. As long as one's true, we're fine. So even at 7, that was left open, yes? Is 7 greater than -2? So it's included because it made one of the statements true. And on the other hand, both have to be true. That's why we don't leave. If this had been an and statement, the 2 sides would have been excluded. And we can't include 7 because it doesn't make both of them true. So and both have to be true, or as long as one of them's true, we include, that's all we have to have. So when they point towards each other, it includes everything on an or statement. But if y'all feel comfortable with this here, we're done for the day. Y'all feel comfortable? Yes? Go on and